Has everyone been here before? Most of you have been here before, yeah. Yes, yes. So we are, I mean, you probably know that. I can just repeat it also for online. We have this little community, and we're meeting every 2 months, I think. Right now, we're trying to have some presenters, some speakers, showing some experience and some things they've been doing in embedded systems. It's a very wide scope of topics, so we do everything from hardware to software, looking at the lowest level, the electronics, up to the highest level, like the software and implementation. So we had already a lot of talks about how to write Linux drivers and that stuff, but we also had talks about, how to drive an LED or something like that, which is very low level. And so it really depends on the kind of speakers we have. So if we have a speaker who's really interested in the electronic side, I would be happy as well to have that. And if you have speakers more interested in the software side, that's also good. So I think today we will have talks more on the software side, some Java, some C probably, and some Linux. I'm really happy because I know that setting up a Linux system, it's much easier nowadays than it used to be. But there's still a lot of magic that goes on underneath with device trees and with kernel configurations. And just to configure a Linux kernel now there's 10,000s, I think. Probably 100,000. I'm not sure the exact number, but there's a lot of things you can change and swap. So yeah, thanks very much for coming. Thanks very much for everyone who's joining us also online on YouTube. I hope these talks will be recorded. And yeah, right now we don't really have a platform to advertise the socials. So I decided earlier last year that I wasn't so happy that Meetup increased the fees or tripled the fees. They're now taking over by, I think, another company, Bending Spoons. And to me, it just seems a money grab for no service. So we're still in the process finding some other platforms so we can better advertise the events and communicate better. So right now, the main communication is the WhatsApp group. And if you haven't joined the group and you'd like to join, I will put up a link, or you just ask me and I can show you the QR code for the link. Most socials will be advertised on the Meetup group. So no, not on the Meetup anymore, sorry, on the WhatsApp group. So I apologize that this one was advertised a little bit short notice, partly because I was super busy the last week. So yeah, so hopefully we will have more talks this year, having some plans maybe also to do a workshop. Depends very much on interest and how many people would want to contribute or help with that stuff. So not to take you too long, Josue Hernandez, no? Hernandez, Josue Hernandez. He is very familiar. He's already done, I think, at least 2 talks, right? So that must be his 3rd talk. So he's been already explained this a lot.
He regularly gives talks in Linux Kermel as well, so
yeah.
I think he's more than 2 now.
He's a star. He should get a medal for the most contributions. So, and this is really what we need. If any one of you also likes to give contributions or do another talk, if you have already done one, so you're very welcome. So we're just going to set up for a few minutes and then hopefully we can start. Do you need anything else? Like a mouse or something? It's fine, no?
It's okay. I have a software in my cell phone that is going to help me with that.
Okay, I'll just give you this one and then get out of your way.
Okay. Play configuration. Is the HMI working? No. I think is this connected or?
You'll have to write the driver right.
Yeah, I think it is. It is disconnected. I think. Yeah. I got to write a driver for that.
Back to the future.
Okay, yeah.
Oh, perfect.
Already. Let's start. Yeah, KDA was the problem, right? Let's see. Give me a second. Okay. Slide, presenter view. This is not the one that I wanted. Give me a second. Display configuration. Where do I can avoid having mirrors? It's like this, right? Okay. The built-in one, this is the other one. This is going to be the main one. Sorry, apply. Okay, that's it. Now, escape. This is going to be from this. Is from this side. And what is? F12. How do I get the full presentation mode? Let me check. Slide. We are ready. Yeah. I think we are ready. Okay, no. Sorry. This one is the one that I have to take to this part. Yeah, sorry. I'm kind of trying to make this easy. Okay, let's start. Can you hear me? Yeah, okay. Well, probably some of you already know who am I. Yeah, who I am. My name is José David Hernández Gutierrez, and I'm going to present today in this group how to build your own simple Linux distribution. Well, just okay. Before we start, I have to mention for the ones who doesn't know who I am. I have been a Linux software engineer for around 10 years, and I have been working in the IT industry for around I don't remember. There's so much time, but. I have been working in projects like Clear Linux and Oracle Linux as a distro maintainer, also building the distribution. Yeah, that's basically who I am and why I'm capable to talk about these things. First, a disclaimer that everything that I'm going to say in this presentation is my responsibility, and it is not a responsibility for the company that I am working on. And this is mainly for legal reasons, because if I say something that someone disagree, they have to sue me and not the company. Yeah. But yeah, I'm going to try to be. I was thinking in a short presentation, but Franz told me that it could be as long as I want. But anyway, I'm going to try to do the presentation in the way that I was thinking of. This is basically the topics that we are going to be talking about. An introduction, basically the three basic components, and how to put them all together. What else? Nothing else. Let's see. What is a Linux distribution? I think at this point, at least in this technology area, every one of us have heard about Linux distribution, right? But what is it and how it is component? We could have some examples here that are really popular, Red Hat, Ubuntu, and so on. But basically, what the people refers as a Linux distribution is an operating system, as in many other industries is known. As Windows is known, that is a Linux distribution, but the Linux distribution has the characteristic that it is using the Linux kernel. It could be a distribution without the Linux kernel, yes. It could be a hard distribution that has a different kernel but have the same components. There is a discussion around it about if it should be called Linux or GNU Linux, but that is a discussion that is not really important, because at the end of the day, if the tooling is GNU or not, we can call them Linux distribution because at the end of the day, they are all the components together being shipping for us. Okay, I don't know what to say. Anyway, as I was mentioned, there are three basic components that you can find in every Linux distribution. A bootloader, a kernel, and a rootfs. What a bootloader is? A bootloader basically is the first process that you are going to run after the computer starts. It is as simple as that. It is commonly going to boot the kernel. And the kernel is going to be the component of your system that is going to be handling the hardware. It is going to be managing it. And it is going to create some abstractions for you in order to help you to handle the operating system without being thinking in what you are doing every time that you are doing it. And the rootfs is basically what you are going to be interacting with. Because at the end of the day, the rootfs contains all the binaries that you are going to be using in a common day, including the init process. But we are going to go into that in a moment. What the bootloader commonly provides to us, or what is it intended to be doing? It provides some hardware description. I don't know, probably you know that there is a difference between running Linux in an embedded device than in x86 computer, and that is because the bootloader in the embedded system is going to provide you the hardware description. It's going to tell you what is going to be in the platform. It probably doesn't know, but it is going to pass the needed information to the kernel during the boot process. Other thing that commonly bootloaders are doing is they run checks for security. What does it mean? There is a component that is considered a bootloader tool that, for example, is called shim. That this small component is going to be loaded at the start, and this component is going to be running another bootloader to load the kernel. But this component is going to change the certificate that you are going to be using for security boot in order to don't have the same signature that is handled by the manufacturer, and you are going to be able to have your own certificate to sync your components. Yeah, it's a bit complicated, but yeah, it's another kind of bootloader. And of course, they provide user interface to select what kernel you have to boot. This is the common thing that we think when we think about a bootloader, because probably in the old days, we remember that when we want to install Windows and Linux, we wanted to edit our group and have some different bullets for our Linux distribution and for the Windows one. Of course, it is going to set up the kernel parameters because the kernel parameters are needed to be passed to the kernel in order to the kernel knows how it is going to behave, and it is going to boot the kernel. Yeah, but at the end of the day, all this doesn't matter at all because the bootloader could be replaced. You probably could not need it, but anyway, it's just a curiosity. You can embed all these stuffs inside the kernel and root your kernel with your bootloader, but it's a bit tricky, but it is possible.
One question. So a few minutes ago, you were talking about the difference between embedded systems and x86 architecture. So the bootloader would be the equivalent of the BIOS into an x86, or what are the
It's a good question. In some documentation, you are going to find two types of bootloader. There is something called bootloader in an stage one that is commonly known also as BIOS in the case of x86 or the firmware, but it is not the same in all the documentation. But commonly, also the BIOS, the difference with the firmware or the BIOS or UEFI or whatever other firmware that you are using is that their software is born into a ROM memory inside the platform. But it's basically doing something like that because at the end of the day, the BIOS for x86 is providing you the hardware description. You are not using device tree in x86. And device tree is the common way how you get the device description or the hardware description in embedded Linux. But anyway, okay. Next one. Some examples of bootloaders that we have. We have this group. I think it's the popular one. Many of us have fight against it for a misconfiguration. There is an old one that is called Lilo. Lilo stands for Linux Loader, but it is already kind of deprecated because it works with MBR, Master Boot Record. Right now we have eLilo that is the one that runs with UEFI. Someone that is too familiar for me is System Deboot because when I was at Clear Linux I worked a lot with it. And System Deboot is the one. Yeah, System D is everywhere. It is also in the kernel, in the bootloader, sorry. And the most used set, but probably not too much known, is SysLinux, because at the end of the day, many ISO images that we have are running a variant of SysLinux that is called ISO Linux. SysLinux have some more variants, like PXC Linux, that is a bootloader that allows you to boot from a remote device, from a remote server. You are going to download the kernel image and you are going to boot it. And the last one is the popular one for embedded system that is called U-Boot. But there are others, like, I don't remember the name, is Bearbox. Yeah, it's another one called Bearbox. Okay. Okay, for the purpose of this talk, we are going to be just touching a bit about how to make a basic configuration of a bootloader. This is how commonly we are going to do it. We need the source code, of course. In this case, we are going to download the group version. I'm not too familiar with group. I would prefer probably System Deboot because it's the one that I'm familiar, but I know that probably many people are familiar with group. And it's as simple as compile it, and obviously we have to refer what buffer we are using. Also make it and perform an installation. In this case, the installation is going to be doing in a custom folder because we don't want to affect the system that we are running. This installation is not going to install your bootloader in your boot partition. This installation is just going to install the needed software to perform that installation in your boot partition. And yeah, basically we can keep this in mind whether we have a bootloader. Sorry. Let's talk a bit about the kernel. Okay, are there questions for this? Probably. Okay. Anyway, let's talk a bit about the kernel. The kernel do lots of things. It manages basically everything in the system. Probably someone could think that process management, memory management, and hardware and device management are the same, but they are not exactly the same. The hardware interaction is how the components interact without the user knowing that is happening. There are certain protocols that the kernel is doing behind the curtains, and you don't know about them. Also, the process management is about forking process, making trees, and everything about the scheduling. Memory management is basically exposing the memory that the system has to you, even if the memory is not when you. What do you think? Probably you think that it is RAM, but it is disk. Yeah. It is something that the kernel do, security and networking, and so on. Yeah. Also, the kernel provides an abstraction layer to interact with the user space. That is something that we already talked about in our presentation. That is the system call interface. Yeah. And device drivers. It load them. Load them. Well, these are what do we need to configure the kernel? The thing that we need to configure the kernel, there are two important things that we need to configure in the kernel. The first one is the kernel configuration, of course. It is going to tell us what parts of the kernel are going to be loaded and in what mode they are going to be loaded. They could be loaded as a built-in inside the kernel binary, or they can be loaded as a module that is going to be loaded after boot. The common ways to set it up is use a default configuration. The kernel has lots of default configuration, and if you're running for a platform, you can download the default configuration for your specific platform, and probably you can download the source code for this platform, and that source code is going to have a default configuration for sure. You can do your custom configuration, or you can simply select the default configuration and modify it and make your own tweaks. In the case of the hardware description, it is basically setting up the device trees. As we remember in the, probably not, but as we as we talk in the talk that we mentioned, in the presentation that we talk about the device drivers in a Raspberry Pi, we mentioned that the device trees are going to describe how the platform is, but we also describe another kind of way to describe the platform. Okay, I already mentioned that actually when I mentioned about the BIOS and so on. Yeah, this kind of conversion is just needed when you don't have a platform that describes you the device. Sorry. Yeah, tell me.
So I'm aware that the kernel has a lot of configurations.
Yeah.
Some of them are not relevant. If other configurations are not enabled, how is it handled? How do you handle constraints within this configuration? So when I change one configuration, maybe I need to change something else.
Yeah. You need to be playing with it, but there is also some tooling that is going to help you to understand or to avoid to be broken something. If you probably disable a configuration, but that there are some configurations that depends on it, there are some tooling that is going to help you to avoid that. But anyway, I don't know. That answers your question? Or?
Yeah, sure.
Okay, okay.
I think I've actually seen that tool.
Yeah, kind of. For this presentation, we are going to be setting up the kernel configuration, and we are going to take the default kernel configuration and we are going to modify it just a bit. We are going to get the minimal kernel configuration and we are going to modify it in order to be able to get a TTY and load an init ramfs. It is not really complicated, but okay. This is what we are going to supposed to do. We are going to get the kernel. We are going to get this configuration. This is one of the many configurations that the kernel have, and this one actually is kind of the minimal one, and is present in different versions of the kernel.
Yeah, thinking about people that use Get2, for example, that they love to recompile everything in the system, is really an advantage to configure precisely what you have, or it's really not that different between the vanilla kernel that is precompiled and compiling yours?
It would depend. If you want, if you are working in an embedded device, probably you are going to need to have something more specific. But if you are in a normal computer, probably what your actual distribution have is enough, because you are not going to be using specific things that are not provided by your distribution. Or probably if you are the Linux distribution commonly have a kernel compiler that has a lot of modules that are installed as a module. Then they are going to be loaded after boot with a mechanism that is called kernel event. The kernel is going to trigger an event, and the init process is going to detect that event, and it is going to load the proper module. If your computer doesn't have it, the module is not going to be loaded. And yeah, you don't have performance penalty for that. Probably you have it just loading it, but it happens at the boot time. You are going to, while you are working, it is already loaded. It's an interesting mechanism, but probably we can go deep into that. But it's more kind of between programming and hacking things. Okay, this is basically what we will need to do is use the default configuration tinyconfig, and we are going to need to enable these other features in the kernel. Because the tinyconfig is by default 32 bits. It is not 64. Then we are going to have to enable 64, TTY, print K. This one to have a terminal, and this one to have information about what is happening in the kernel. And init ramfs, because we are not going to be mounting a device. We are going to be using a CPIO file that is going to contain our rootfs, and the elf binary obviously to run the init process, because the elf binary execution support. The kernel has that support inside, because it is going to run the first process. The procfs and sysfs. This is just to be in compliance with what the application requires, because some application requires to read from proc, and some application requires to read from sysfs. And there are other temporal file systems like dev TMPFS, but they don't need to be enabled, because they are enabled by default. Is too common to. It's something that everyone is commonly using. Yeah. For this, actually, this tool, make menu config, is going to trigger us it is called course, a course window that is a terminal window that is going to help us with what do we need to set up. DUI?
Yeah.
TUI, terminal user interface. Yeah.
DUI.
T. Yeah. No. Terminal user interface. And it commonly looks like this. It is not really pretty, and you have to know the commands. The commands are commonly written above, but I took a description of just a part of the window. But the way to set it up is just press space, and you can also search with the slash. If you don't know what configuration you need to, where the configuration is, you just can type slash and search for it. But in this case, we are just going to set this one, and we are going to enable TTY when we, what is it? Anyway, I'm going to point with my finger. When we enable it, all these are going to enable are going to be enabled by default. This is the kind of thing that I was talking. This is the tool that I was talking about. This tool is going to not allow you to remove this because all these are dependent of it. This is the kind of thing that are going to help you. This is the way how kconfig is going to help you to set up the kernel. Kconfig is a build system that is probably a topic for other talk. It's too big. It's really too big. And too interesting too, because there are other platforms that are using it, like BusyBox, and also I think Zephyr is using it, I think. But yeah, we are going to enable print case. This is how it have to be seen.
So print case,
oh wait.
printing function for the kernel.
Yeah, print case is the function that is going to print information in your TTY, and you are going to see what is happening. If something is broken, and you are going to see it. Otherwise, you are just going to see nothing. You're going to see a black screen that is not advancing. This is the, wait, I think I missed one. Okay, yeah. Oh. Well, anyway. In this one, we are going to set up proc and sysfs. Again, you can find for it, and all the things that are dependent from it are going to be enabled by default. This is the default configuration. You can also add an additional things if you require it. And also, if you remove some of them that are dependent, they're going to remove it. I miss a couple of examples for the other one. Yeah, I missed them. Anyway, but it would be the same for these two one. In it RAMFS.
The system will not execute anything because you didn't enable it.
Yeah, actually, but and yeah.
So that was menu config. Like that's after you ran make tiny config and that kind of like.
Yeah, because there's a good question. Actually, I forgot to mention that. The thing is that the kernel is going to take the kernel configuration from a hidden file that is called .config. It is hidden in the source code. Then when you build the kernel is going to looking for it. Then if you make a make tiny config, makefile makefile is going to copy the configuration for the tiny config in your root file system, in your root source file system as a .config, and when you are running make menu config, you are going to be able to modify the .config. Then that is why we need to do this before continue, because we are going to be using the minimal one. Let's check. Okay, we already mentioned this. What? No, this is not. Yeah, once that we already have all this, what we are going to do is just make it, build it. I used to use this parameter, minus G, and the mproc in order to run some process in parallel. mproc is going to give you the amount of threads that your computer support. And once the compilation is finished, in the case of x86 system, you are going to get this B0 image in that folder. Nothing? Okay. Well, this is basically how we are going to get the kernel. Now we already have the bootloader and the kernel. Now we are going to talk about a bit rootfs. As I mentioned previously, the rootfs is going to give us the init binary. The init binary is the one that is in charge to mount the TMPFSs, the proc, sysfs, and the dev one. It also is going to be handling the kernel events, loading the modules if that is the case. If you don't have modules, in the particular case of tinyconfig, tinyconfig doesn't include modules. It has all the system built in. Then we are going just to copy the kernel without copying all the modules. But if that is the case, you will need a system that read the kernel events and load the kernel modules. And in common Linux distribution, that system is known as UDEP. It was a different project once upon a time, but right now it's practically inside systemd. You commonly are going to see them shipping in the same kind of package. Also in your rootfs, you are going to see the common configuration files and a user interface, probably a bash. In this case, I decided, in order to save time, I decided to show you a repo of my repository for an initRD process. We can go and check for it. Where is my mouse? GitHub.com. I'm not signed here, but what's it? I don't know. Okay, let's continue. We can go for it in a way. Basically, what it is doing is just create symbolic links for the BCBox binary with the name of the binary that we want. As BCBox is going to get the argument 0 for what are you pretending to do, and it's going to mount all the TMPFS in order to be able to run. But then this is the way to build it in my system. But what is BCBox? You can be asking yourself. It's a BCBox? Yeah, BCBox is a set or is a suite of tools that are shipped in a single binary. It is basically a really large, or not too large, but a good amount of Linux tooling like CAT and some mounting system. There is also Bash, and there is another one that is called MDev, that is the equivalent to UDev, that is going to help you with the kernel events. Are we okay on time? Okay. And basically that is VisiBox. There are other tools like that, like TinyBox, but they are not too popular. VisiBox is more popular, but TinyBox is the one that Android is using, mainly because of a license. Because VisiBox, I think, is GPL. I don't know I don't remember if it is GPL 3 or GPL 2, but it is GPL, and some people is scared about GPL. Anyway.
I kind of remember that when you have the system, you have all the executables linking to just one executable. So in your file system, you still have all the Linux executables, but they all link to
that is basically what my script is doing. I'm using a tool that is inside VisiBox that is just, you just have to call VisiBox install and it is going to perform that. But the thing is interesting because when you are writing a program in C, commonly you get the arguments and the first argument is the name of the binary. But it's not just the name of the binary, it is the name how they are calling you. Then if you create a link symbolic to it, you can know what command they want to execute, just getting the first parameter. That is basically how VisiBox works.
What is the rationale? Is it to save memory space, or to make the application smaller? To just have it in a single binary?
Yeah, kind of. Also, I think it's simplicity. It is too common in embedded systems. But at the end of the day, you cannot have all the complex configuration that you could have in a server with this kind of tooling. These tooling are just to have something to write a terminal, to write things, or to execute another programs, but it's not really. Yeah. There are some people I have seen that there are some people that combines VisiBox with another programs. But to do that, you have to have another elf interpreter in the rootfs. You already have one in the kernel. But okay, sorry, I'm getting excited.
I have seen VisiBox being used in the terminal for an emulator in your cell phone, for example.
Yeah? Oh, okay.
So Thermos actually use VisiBox.
Oh, okay, I didn't know that. Yeah, I mentioned TinyBox because some years ago when I was working for testing device drivers for Android, the Android platform behind the curtains in the system level, behind all the Java stuffs, they used to use TinyBox. If you want that layer to debug it, if you don't want it, it is not going to contain it. But anyway. Yeah, and we already have a rootfs, a kernel, and a bootloader, but how are we going to put everything together? Well, if you want to test what you already have, you can just run Kemu, but Kemu have his own kind of boot system that allows you to run it run the kernel isolated and your init ramfs. You can run it like this, just passing the kernel that you already have and the bootfs. But if I want an image, and probably I want to install it in my machine, it's up to you. But what would you need is mount the device, the target device. Probably the target device could be a virtual image, or it could be a real hardware. And practically copy everything or install, in some cases, everything on it. And that is the other part of the process. Basically, we started building from bootloader to rootfs, but in this case, we are going to go in reverse, kind of, because we can just make a copy of the kernel in this case, because in this case we have this tiny configuration that is everything in the image. But if we have kernel modules, we are going to need to perform a make install with a destination to the path that we want, because make install is going to perform other things. And we are going to need to copy the init ramfs. The location doesn't matter, because at the end of the day, we are going to set the bootloader to find them. I just put it in the root UFI partition, in this case UFI, but you can put it, you can create your special folder if you want. This is going to be basically the menu config that we are going to need for run our specific kernel with our specific rootfs, in this case an init ramfs. It's pretty simple. Probably, if you are running, okay, it is something that I wanted to mention, but I lost the opportunity. I'm going to mention as a curiosity at the end. Yeah, and it is simple. It's basically where your kernel image is and the kernel parameter. You can add as many kernel parameters as you want with the configuration that you want. Probably read-only or something like that. But in this case, we are just using init RT. Also, we can set up with which binary we want to start. And finally, we are going to use a groove MK standalone to create, to create our ELF binary. To create our EFI binary that is going to be loaded, and it is going to be that is going to be loaded by the system. Why I'm using this one? Because this one allows to avoid all the configuration in the rootfs. There are some commands from Groove that allow you to do all this from the rootfs, but it implies that you are in the system. That you have /etc/groove/default groups configured, but we are not in the system. We are pointing to another system, and also we are checking for that configuration. And at the end, practically all the systems, all the UFI systems are going to be loading the first ELF binary from this path. This is practically always the same, but if that is not the case, you are going to need to check your EFI configuration management, boot configuration management, sorry, in order to see where it is pointing or modify it. There are some things that are stored in a NBA inside your machine that is going to decide that. And okay. Then you can ask, but if I have this distribution, every time that I want to modify something, I have to perform all this. The truth is that that's right. That is why we don't used to do that commonly. Even in embedded system, if you want something custom, you don't have to do this. This is just for demonstrative purposes, to know that this could be done, but this is not the way to do things. For that, there are other kind of tools. You can probably you already know some of this. This one I discovered it some weeks ago, looking for an OTA mechanism. The other one, the one with the helmet, is buildroot. It's a common tool that is based on makefiles and it is going to perform basically everything that we are doing just with a couple configurations, and you don't have to be doing all this everything every time. And the last one is probably my favorite one, that is when it is bigger, is Yocto project. That is an interesting tool that it needs some kind of recipes to work and so on. They have a really big adoption in the embedded community. Okay, and that's it. Sorry, you want? Let's see.
Maybe there's some more questions.
I have a question.
Maybe the microphone.
Which architecture is the ISA? Because when you mess with your distros in GPG, you look an ARM distribution in AMD hardware. The bootloader breaks the system and says, hey, run processor, run architecture. So which architecture is the bootloader?
Yeah, it would depend, because in the case of x86, it is going to be x86 of x86 64, because the processor doesn't understand nothing that is not in his architecture. Probably the question is what format it is, or
The bootloader runs in the processor?
everything runs in the processor.
That's the question. So if you have a group x86 running in an ARM architecture, group is actually running and it's failing at kernel root. So what is the binary format if ARM can execute the x86
Yeah.
boot?
I'm not sure if that is the case. Actually, I haven't seen that personally, but what I remember is that certain ARM processors have a kind of binary translation. That could be what is happening in that case, because in the reality there are no reason to be running a binary from another architecture in a processor of a certain architecture, right? Yeah, it could be the case, because everything is running in the processor at the end of the day. The BIOS is just a piece of memory, and the bootloader is also another piece of memory.
So the BIOS can't run anything, no? It's not a microcontroller or something?
No, actually you can build, in the case of UEFI, you can build ELF applications and just put it in your ELF partition and run them. There is something called EFI shell, and the EFI shell, you can load your kernel or you can load your EFI applications, and it's an interesting.
Remember we talked about the guy who programmed games for BIOS?
No, I don't remember it. I talk about it. Okay, I don't remember. Yeah, but.
Well, maybe the BIOS can run something.
Yeah, at the end of the BIOS is just a piece of memory. The BIOS is going to be loaded in the processor memory and it's going to be run. It is probably someday we are going to we can talk a bit about that. I'm pretty sure that the guys that know more about the electronics know more about this than me. But basically, the processor is going to fetch information from the memory. And there is a register that is going to be pointing to a certain location, and it's going to execute that and move. And then when you are running the BIOS, basically you are getting that piece of memory loading in memory, that piece of run memory loading in processor memory, executing it, and when the bootloader is changing for the kernel, it's just loading another piece of information in memory and running it. Kind of. Some more questions?
I do remember that I was once setting this up on FPGA, and I think you need a cross-compilation toolchain as well.
Yeah.
So, I mean, everything is compiled basically from scratch for the architecture. So, if I remember correctly, but yeah, usually you don't have any emulation or anything in place, it's just bare metal.
Yeah.
You don't want to be
Look.
compiling your kernel in your Raspberry Pi.
I mean, the
Look.
customization stuff, and then just send it over to the target system. And usually just, depending how the target system works.
Basically, if you want to do something like that, you are going to pass to the kernel this kind of flags that is going to give a prefix for what binary you are going to be running. And in this case, I'm running this binary that is going to build, is going to produce an ARM64 binary, but the binary itself is x86. I don't know if that's clear. That is called cross compilation, and this is in order to be working in a powerful machine for producing binaries for an embedded device or something like that. Yeah, but let's see.
I was going to extend it to the comment that you did about some code or some BIOS firmware that is programmed for x86 architecture that can run into a ARM architecture up to a certain point. There has been kind of efforts from the ARM perspective to kind of I don't know how to say it, to make some native translators into the ARM SoCs. For example, have you seen the silicon from Apple?
Yeah, the M1.
A certain IP called Rosetta Stone, which natively attempts to translate complex instruction from the x86 set to the reduced instruction from the ARM architecture. So there has been continuous effort to kind of have native support in these kind of translators that are embedded within the SoC from different architectures. Yeah. So Rosetta Stone is one of those that are very popular right now.
Kind of.
Any more questions? Yeah.
The EFI system, is that something like after the bootloader gets set up, it kind of loads the EFI
Yeah.
in parallel with having the option to boot the kernel?
Yeah, basically the EFI system is the equivalent that we have in old days that was called BIOS, but the UFI system is a fancy one. The thing is that the difference is when you have BIOS, you have to have a master boot record, a sector of your disk when you are going to put your binary raw, and it is going to be executed. And with the UFI, UFI is going to mount an FAT32 file system, and it's going to looking for a specific file. And also there are some other kind of fancy stuff that they have, but yeah, it's basically a system that is built inside your platform. There is a ROM there, and there is a ROM there.
I don't know. Do you remember the Amiga computer?
Yeah.
Because that was very funny. It had just a small piece of code that reads the boot sector that runs that code.
And now it's like a Robert Gordon machine, right? Because we have the hardware, which boots UFI, which boots IDRAMFS, which boots
Yeah.
kernel. So it's like exactly.
Yeah, but there is an interesting purpose on that, because at the end of the day, you can change some parts without affecting the whole line. If you want to change the kernel, you just have to change the kernel, and the whole system is going to be exactly the same, or the bootloader. And the bootloader, the advantage that provides you is that you can have the same bootloader for different systems, and the same kernel for different systems, and just the bootloader is the only thing that is going to be caring about how the computer starts. Because, for example, there is a specification that is called multiboot. This is a popular specification that is going to tell you how do you have to create a binary in order to be loaded for a multiboot supported bootloader. Group has support for multiboot, and if you want to create a kernel and you create it for multiboot, you can load it in group without caring about how the computer starts. Some parts of how computers start, because at the end of the day you have to be caring about some of the stuff. But this is another topic.
You can use the
Yeah, some parts of the abstraction. Yeah,
Yeah, there's a lot of things that can go wrong now.
yeah.
Exactly.
So, any more questions?
No.
Otherwise, I'd say thank you very much again for the talk.
Uh,
Very interesting. And I think we should really follow up on this. So it would be nice to have maybe a demonstration at some point, maybe have an embedded device to create the system, and not so much explain all of this again, but just doing the actual demo of it.
Yeah.
So you have another talk.
Okay, yeah, for sure. I actually, my head scale is not working, but I was planning something like that.
Cool.
I don't know
So,
why.
Thanks very much. Can I just quickly have?
Yeah. Okay.
So just to thank Josue again. It was really interesting and seems familiar, but also a lot of new stuff. And for those on YouTube, on the streaming channel, we'll take maybe 15, 20 minutes break, and then we continue with the next talk. And yeah, thank you once again. Thanks so much for that interesting talk. Help yourself.